Hello everyone, this is Professor He. Nice to see you again. The topic of this task is about the types and systems of fuel cells. Let's firstly talk about the classification of fuel cells. The fuel cells can be classified into different types according to the electrolyte, the operation mechanism, and the operation temperature. There are 5 major types of fuel cells, differentiated from one another on the basis of their electrolyte. Based on their operation mechanism, there are 2 major types of fuel cells differentiated from one another. There are 3 major types of fuel cells differentiated from one another according to their operation temperatures. The most important fuel cells are listed in Table 14.5 with their main characteristics. The advantages and disadvantages are: for PAFC, the advantages include the mature technology, the excellent reliability or long-term performance, and the relatively low-cost electrolyte. Meanwhile, the disadvantages include the expensive platinum catalyst, the susceptible to carbon monoxide and sulfur poisoning, and the electrolyte, which is a corrosive liquid that must be replenished during operation. For PEAFC, the advantages include the highest power density of all the fuel cells, the good start-stop capabilities, and the low temperature operation, which makes it suitable for portable applications. The disadvantages include the expensive platinum catalyst, the expensive polymer membranes, the auxiliary components, the active water management required, and the very poor carbon monoxide and sulfur tolerance. For AFC, the advantages include the improved cathode performance, the potential for long precision metal catalyst, the low materials cost, and the extremely low-cost electrolyte. The disadvantages include the poor hydrogen-oxygen needed, the KOH electrolyte occasionally repletion, and the water removing from a load. For AMC-FC, the advantages include the fuel flexibility, the long-precious metal catalyst, and the high-quality waste heat for cogeneration applications. The disadvantages include the carbon dioxide recycling, the corrosive and molten electrolyte, the degradation and/or lifetime issues, and the relatively expensive materials. For SOFC, the advantages include the fuel flexibility, the long-precious metal catalyst, the high-quality waste heat for cogeneration applications, the solid electrolyte and the relatively high power density. The disadvantages include the significant high temperature material issues, the sealing issues, and the relatively expensive components and/or fabrication. Now, let's talk about the systems of fuel cells. There are mainly 7 subsystems for a fuel cell system to maintain its reliable operation. Taking the PAFC fuel cell system as example, as shown in Figure 14-15, the 7 subsystems include: the first is the fuel reforming supply system. The second is the oxygen supply system. The third is the water management system. The fourth is the thermal management system. The fifth is the DC and AC inverter system. The sixth is the control system, and finally, the seventh is the safety system. Finally, let's talk about the performance indicators of a fuel cell system. The first is the net efficiency of AC, which is defined as. The second is the total efficiency of AC, which is defined as. The third is the total efficiency of DC generation terminal, which is defined as. The fourth is the transmission efficiency of DC, which is defined as. The fifth is the bulk cell efficiency, which is defined as. The sixth is the theoretical efficiency of fuel cell, which is defined as. The seventh is the current efficiency of fuel cell, which is defined as. The eighth is the voltage efficiency of fuel cell, which is defined as. The ninth is the process efficiency, which is defined as. The 10th is the total efficiency, which is defined as. And the last one is the fuel efficiency or fuel utilization factor, which is defined as. That's all for this task, and this is the end of this class. Thank you very much for being with me. See you later.